Okay, in this video we're going to look at solving for and finding the measures of certain angles and arcs with our circle geometry. And our focus is going to be on angles formed by the intersection of chords or tangent lines, or even if I have an angle formed by multiple radial lines. And what we can do is we can classify these angles, these circle angles, into three types. We have angles that have vertices that lie inside the circle, where angles that have a vertex that lie on the edge or on the outside. And if I classify them in those three ways, it makes it a little bit easier for us to try to remember the formulas or the relationships. And so what we have is we have two kinds of angles that have a vertex on the inside of a circle. We have what's called a central angle. A central angle has a vertex that lies at the center. And if it has the vertex at the center and the angle formed by two radial lines that intersect on the edge of the circle, the measure of the central angle is equal to the measure in terms of the angle of the arc. All right, so I'm not talking about the length of the arc. I'm talking about the angle measure, or the number of degrees represented by the arc. So the arc measure in degrees would be equal to the arc, or the angle measure in degrees. If I have a vertex for my angle that is not at the center but is still inside the circle, and it is the intersection between two secant lines. All right, so these two secant lines, they intersect the circle, and the relationship that exists here is that this angle C is equal to 1/2 times the sum of the arc of A and the arc of B. So I add the two angles, or add the two arcs together and divide them by 2, and that equals the measure of this angle C here. Now, if I have two angles that have a vertex that lies on the edge of the circle, and so one of them over here on the left is an inscribed angle. An inscribed angle has a vertex that's on the edge of the circle, and it's the intersection of two secant lines. And the relationship that exists is the measure of the angle is 1/2 the measure of the arc, or likewise, take the measure of the angle and times it by 2, and you have the measure of the arc in degrees. And the same relationship exists if you have a vertex that lies on the edge and the angle is formed by a secant line and a tangent line. So the measure of the angle between the secant and the tangent line is 1/2 the measure of the arc that contains, that lies in between the two intersections. And the third classification that we can have is if the vertex of the angle lies on the outside of the circle. And all of these measures in terms of the angle measure are going to be the same. So if I have a vertex that lies on the edge of the circle formed by two secant lines, or a secant line and a tangent line, or two tangent lines themselves, the measure of the angle, in all three cases the measure of angle A, is going to equal 1/2 times the outer arc minus the inner arc. So outer arc minus inner arc times 1/2 is equal to that angle. All right, so that kind of sums it up into three different kinds of angles. And so now let's work our way to start solving some of these. Okay, so let's look here at this first problem. And so our goal is to find the indicated arc. All right, so I'm looking for the measure of this arc here, and we have that this angle is 115 degrees. Now notice how the vertex here is at the center of the circle. And so we have a central angle, which means that the measure of the angle is equal to the measure of the arc. So this is simply 115 degrees right there. So let's look here at number 3. And this time I want to find the measure of the angle indicated. Now this angle is a central angle because it has a vertex at the center. And I'm going to highlight this angle. And I look, and the measure of the arc that subtends the angle is 45 degrees. Which means that the angle measure itself has to also be 45 degrees because it's a central angle. Next one. Find the measure. Now this is the measure of arc LMN. So I'm trying to find the measure of the arc that starts at L, passes all the way through M, and then keeps going until it gets to N. So I'm trying to find that entire arc measure there. Now, we're given an angle who has endpoints at N and L, and that's angle W right here. And so what we have is we have one of those inscribed angles where the measure of the angle is equal to half the measure of the arc. So that means that this arc measure has to equal 2 times 110 degrees, which means that it's going to be 220 degrees. All right, so we're trying to find the measure of this arc here that goes from S to Z. And so we're trying to look and figure out, well, what would the ideal approach be to get that answer? Now, if I look at this piece here, I have a diameter line. And so I know that the measure from the diameter line in terms of the arc is going to be exactly half of that of a circle. So that red arc there is going to be 180 degrees. And we try to figure out, well, how does that help me if the entire arc is 180? Well, so I know 180 is that whole measure. Now from that, to solve for the piece that I'm looking for, what I want to do is I want to subtract the measure of the arc that would go from Q to Z, because we're given this angle right here, which happens to be 53 degrees. And so that would be this piece right here that I want to subtract. Now, this is one of those inscribed angles. So the measure of that arc is going to be equal to 2 times 53, which is 106. So that's 106 degrees. And so if I did that subtraction there, that is going to give me the measure of that arc that I'm looking for, which goes from S to Z, which is going to give us 74 degrees. Now let's look at secant-secant angles where the vertex lies on the inside. And so we're trying to find the measure of what's indicated, which in this case is going to be the arc that goes from M to L. And that's what we're trying to find. I'm going to call that X here. All right, so according to our formula, the angle formed on the inside is going to equal, so 120 is going to equal 1/2 times the sum of the arcs. So 1/2 times 66 degrees plus X degrees. And then I work my way to solve for X. So I'd multiply by 2. That gives me 240 degrees is equal to 66X. Or 66 plus X. And then subtract 66. And that's going to let us solve for X there. And we get 174 degrees is equal to X. All right, so 2 secant lines, and this time our vertex lies on the outside of the circle, and we're actually given the angle here. The angle here is 39 degrees. And we're looking to find the measure, in this case, of the little arc that goes from H to F, and I'm going to call that X. All right, so when the vertex lies on the outside of the circle, the measure of the angle, in this case 39 degrees, is equal to 1/2 times the difference between the outer arc and the inner arc. So I'm going to do the outer arc, which is the big one, so 127 degrees minus X. And then we'd solve from there. So I can multiply by 2. And then I could subtract the 78 and add the X. And that's going to give us x is going to equal 49 degrees. All right, let's look at a different kind here. So let's say I have an angle formed by a secant and a tangent line. All right, and we're looking for what's indicated. So this time, I'm actually looking for something here that lies on the outside of the angle form. So I'm going to call this part x here. Well, in order to find that, what I'm going to first need to do is I need to figure out, well, is it possible to figure out the measure of that arc there on the inside? I'll call that one y. Well, if we have a vertex that lies on the edge of the circle, the angle formed between the secant line and the tangent line here is going to equal, so 35 is going to equal 1/2 the measure of arc y. And so if I wanted to figure out what y was, I'd multiply the other side by 2, and I get 70 degrees is equal to y. So if I know y is 70, to solve for x, I know all the way around the circle would be 360 degrees. So 360 degrees minus the 70 degrees for y would give me x. And we get 290 degrees. All right, let's look here. All right, so angle form, we have a secant and a tangent angle, vertex on the outside. All right, and this time we're trying to directly solve for the angle itself. And so when the vertex lies on the outside of the circle, and I'll just say angle C in this case. So the measure of angle C is going to equal 1/2 times the difference in the measures of the outer arc and the inner arc. So 1/2 times 178 degrees minus 98 degrees. And that would give me the measure of angle C. And angle C is going to come out to be 40 degrees. All right, and let's look at one more right here. All right, so this time we have angle M is formed by 2 tangent lines to the circle. And I want to figure out what M is. Well, the only thing that's given is that the measure of the inner arc is 130 degrees. Well, in order to find the measure of angle M, I'm going to need both arc measures. So I also need the measure of this arc here. Well, if I know that one piece of that is 130 degrees, to get the measure of the outer piece, I do 360 degrees minus the 130. And that would give me the measure of the outer arc. So that's going to be 230 degrees. Now I can go solve for M. So the measure of angle M is going to equal 1/2 times the difference between the outer arc, so 230 degrees, and the inner arc, 130 degrees. And then I would just evaluate that, and we'd get M's going to come out to be 50 degrees.